For lab 3, we're going to be looking at the identity of a liquid. So we're going to take an unknown liquid and using its density and boiling point, we are going to figure out what that unknown liquid is. So in order to figure out the density and the boiling point, we need to get some measurements first. We're going to be doing 2 trials with the same liquid. So for identity of the unknown, trial 1, in the data table, the first data point is the mass of the graduated cylinder. And that is given here as 33.702 grams. The volume of a liquid. So to figure that out, we are going to be measuring it in milliliters. So ml will be your units on that. To figure out the volume of the liquid, you're going to look at the picture to the right. So I have approximately 3 milliliters in a graduated cylinder. And I want you to use your eye to figure out the exact measurements. So keep in mind with this graduated cylinder that it goes to the 10th spot. What I mean by that is this complete circle down here, that is 2 milliliters. The next dash is 2.1. Then we have 2.3, 2.4, 2.5, so on and so forth. So you can see the meniscus of the liquid is approximately right here. So you read how much that is and fill in the volume of a liquid. Make sure that you go to the 10th spot. What I mean by that is if you think it's exactly at 3 milliliters, make sure to write 3.0 milliliters. Once we add the unknown liquid to the graduated cylinder, we then bring the cylinder with the liquid in it back to the scale and mass it once again to get the mass of the cylinder with the liquid, which is 36.024 grams. Now, to figure out the mass of the liquid, number 4, we're going to subtract those two masses. So we're going to take the mass of 36.024, which has the cylinder and the liquid in it, and subtract out 33.702 from it, because that's the mass of just the cylinder itself. So when we subtract those two, what we're doing is we're taking out the mass of the cylinder, and we're going to be left with just the mass of the liquid. Now for the last data point in trial 1, the boiling point of a liquid, we have to set up a boiling point apparatus. So to set up a boiling point apparatus, we take that sample of the unknown liquid and we put it in a test tube. So you can see the test tube right here is submerged in a water bath. We then put a thermometer in the liquid in the test tube, which you can see the red bulb of the thermometer at the very bottom of the test tube. Attached to the thermometer is a capillary tube, and that's what this is right here. This is a capillary tube with the open end in the solution. You can also see a little bubble starting to form at the end of that capillary tube. So to get an accurate boiling point, what we want to do is heat our liquid up until we see a steady stream of bubbles coming from that capillary tube. That tells us that we are very close to the actual boiling point of the unknown. Once we see that steady stream of bubbles, we go ahead, like we can see in this video here, and remove the test tube from the water bath. Once the bubbles stop, that's when we record the boiling point. So for trial 1, the experimental boiling point that I got when I did this was 79.5 degrees Celsius. So I've inserted that into number 5 in the table, 79.5 degrees. And we're going to do the same thing for trial 2. So for trial 2, we're going to now use approximately 6 mils. Now you'll notice this time when you're looking at the graduated cylinder off to the right that is not exactly at the 6 mils, because 6 mils is this line right here, the 6.0. So it's a little higher. So use your judgment and figure out just how high. Is it 6.1, 6.2? That's for you to decide. Now, the mass of the empty graduated cylinder is the same because we're using the same graduated cylinder that we did in trial 1. Once we fill this up to approximately the 6 mil mark, we masked the cylinder with the liquid in it to get 38.602. To figure out the mass of the liquid, then, you're going to subtract these two numbers so that you subtract out the weight of the graduated cylinder and are left with just the mass of the liquid itself. We did the boiling point of this one again, this time getting an experimental boiling point of 81.0 degrees Celsius. So you can put that in your table. Now for the calculations, for number 1, it wants you to use the values from the data table that we just collected to determine the density of the unknown liquid. Now remember, we used the same unknown liquid in both trials. So we're going to calculate the density of the unknown liquid by using the density equation. And that is where we take mass, measured in grams, divided by the volume, measured in milliliters. So for trial 1 to do this calculation, you're going to use the data in the data table from the trial 1. You're going to take the mass of the liquid that you calculated by subtracting the mass of the cylinder in the liquid minus the mass of the graduated cylinder. Then you're going to use the volume of the liquid, which was approximately 3 mils, but use exactly how many you think it was. When you divide those two, you'll get an answer with units of grams per milliliter. Mass divided by volume, grams per milliliter. You're going to do the same thing for trial 2, but using the data from trial 2. So the mass of the liquid in trial 2 should be greater. The volume of the liquid in trial 2 was a little more than 6 mils. So enter those values in to calculate the density in grams per milliliter for trial 2. Now the next question, number 2, wants you to determine the average density. So since we used just one liquid, we used the same liquid, we're going to use this spot here to calculate the average density. So to calculate average density, you're going to use the density that you calculated for trial 1 and add it to the density that you calculated for trial 2. Then of course, divide by 2. It also wants you to report the boiling point of your liquids, so you can do the average boiling point there under number 2 in that space as well. Now that we have all the data we need, we're going to identify our unknown. So there is an unknown liquid key on page 15, and I have the same key posted in this table here. So you're going to compare your values that you got for average density and boiling point to the values in the table here. And based off of those values, you can identify what your unknown is, what the liquid is. So I'm going to start with boiling point since those were given to you. So the two boiling points we got were 79.5 and 81.0. So to figure out the unknown, you just look at the boiling points in the table and see which ones are close to the boiling points you were given. So 56.2, that's way off, so we know it's not going to be acetone. 78.3, well, that's a possibility because 79.5 isn't too far off from that. For isopropanol, it's 82.4. Well, we did get one of the boiling points at 81, so it could be isopropanol as well. Methanol's at 64, so that's way off from the boiling point we got from our data. Water's 100, and that's also way off. So now we've narrowed it down to 2 possibilities. So what I want you to do is use your density, your average density calculation, and compare to the 2 densities of ethanol versus isopropanol. And whichever one is closest, that will be your unknown. Once you have identified what your unknown is, and you'll see in number 3 there are 2 spots, one that say liquid number and identity. Well, we only used one liquid, so you only need to fill out one of those spaces. So the liquid number, it doesn't matter what number you put there, you can put number 1 if you just want to fill it in. And then under identity, you would write which one you thought it was based off of your densities. Did you think it was isopropanol? Or what was the other choice? Isopropanol or ethanol? So now the last calculation, number 4, they want you to use your accepted values to calculate the percent error for density and for boiling point. So to calculate the percent error for density, we're using our percent error calculation, measured minus true divided by true. Notice the absolute value bars mean that it's going to be a positive value. Don't forget to multiply it by 100 to get it in a percent. Now, what are you using as the measured? The measured is your calculated average density that you calculated using the data in your table. For true, you're going to plug in the known density reported on the table. So what I mean by the table is this table here. So we were between ethanol and isopropanol. So these are the values, the known values for ethanol and isopropanol. So your true is going to be either 0.785 or 0.804, depending which known you chose. Now you also need to calculate the percent error for the boiling points. So using the same equation, this time plugging in your boiling point values. So for the measured, it's the average boiling point. So the 2 boiling points given were 79.5 and 81.0. Add those together and divide by 2 to get your measured value. And you will plug that in to the boiling point equation. Now for the true value, once again, look at that table. Which one did you choose? Did you choose ethanol? In which case your true value for boiling point would be 78.3. Or did you choose isopropanol? In which case your true value will be 82.4. And that's the last calculation of the lab.